For this video, we're going to focus on a topic called molar mass. It's one of my favorite topics in chemistry, so sorry for the excitement. Regardless of whether I'm your chem teacher right now, I get to introduce molar mass to you, which is very exciting. So in order to do this video, you need to open up the notes that go along with it. So in this folder, you'll have the note sheet. Open that up, okay? And then the topic we're focused on here is called the mole, and specifically, we're going to focus on the molar mass component. Okay. The last lesson went through kind of an overview of what the mole is, being Avogadro's number and a really big number and things like that. This video is really about the practicality of the mole. How, as chemists, do we use the mole to do stuff? Okay. So, specifically for the mole, here's a little bit of a review from the last video and a little bit of new information. Okay. When we work with the mole, M-O-L-E, you will find as a label, it's abbreviated just to M-O-L. So if you're counting like how many moles of something that you have, what you'll find is it'll say something like 5 M-O-L. You don't have to write the E. You're welcome. Okay, so when it comes to chemistry, one of the things that's hard about chemistry is we can't count the atoms. Okay, when I have like a sample of water, I can't tell you, oh, that holds 15 water molecules because I can't count them. But when it comes to chemical reactions, we need to know how many in order to talk about how they're reacting with one another. Okay, so the mole was something that was created by scientists in order to help chemists do the math and kind of the thinking about the materials they're interacting with. Okay. So just like the video said, the mole is kind of like a scientific dozen. When I say I have 1 dozen eggs, you know that doesn't mean I have 1 egg. That means I have 12. So if I have 1 mole of any sample, that doesn't mean I have 1 of that sample. That means I have 6.022 times 10 to the 23rd of that sample. That's a gigantic number, as the video told you, and we won't really work with that number much because it's not that useful for us. Okay, because I can't go into lab and count, as I just said, but I can go into lab and get the mass. So what the mole actually allows is we have this bridge that allows us to go from counting to massing, which is what matters in chemistry. Okay, so not only does the mole mean I have this random number, 6.02 times 10 to the 23, it also means I have a certain mass of my material. Okay, and specifically, it is the atomic mass of that material. Now, I have this amazing calculation right here showing you how 12 grams of carbon is also 6.0 times 10 to the 23rd. And you don't really need to worry about that much. It's just there as a demonstration to you of how the mole relates. But again, practicality is kind of what the mole is all about for us. And so what we're going to focus on is this definition. The idea that 1 mole is the same as the atomic mass of any substance that you want to measure. But the way a mole works is it gets us to grams, which is helpful because I can go into lab and actually measure grams. I have gram scales in lab. So with this unit now, you're going to need your periodic table again because the periodic table contains our atomic masses. So back in other units, we looked at the periodic table in detail and we looked at these numbers, right, that exist underneath the atom. And what we talked about was those numbers, okay, so like 12.011 for carbon or 14.007 for nitrogen. In the past, we talked about how those were the average atomic mass for any sample of a material, okay? So if I had, 1,000 atoms of carbon, on average, they would be 12.011 AMUs, atomic mass unit. Again, because I can't count per atom, that measurement is not really helpful for me. But again, that's where the mole comes in. So if I have a whole mole of carbon, that material will mass out to be 12.011 grams of carbon. And if I have a whole mole of aluminum, so a chemical dozen of aluminum atoms, and I put them on a scale, they would mass out to be 26.982. So the mole is this bridge between counting particles and massing them. And thank goodness chemists are smart and they used these numbers that we already had on the periodic table in order to define the mole. So while the number 6.02 times 10 to the 23rd seems really crazy and arbitrary, it's a beautiful number because it relates directly to the periodic table. And that's kind of the goal. So molar mass, this amazing term. Molar mass is what we call atomic masses that we're reporting in grams. So if I look at atomic mass, atomic mass of carbon is 12.011. If I then talk about that being the grams of carbon, that becomes the molar mass. Okay. The general term of what molar mass means is a molar mass is the mass of 1 mole of any substance that I measure in grams. Which means I could get like the molar mass of pencils if I want. Okay, if I had a mole of pencils, 6.02 times 10 to the 23rd of pencils, and I got the mass of them in grams, that would be the molar mass of pencils. Okay, if I got a mole of popcorn kernels and got the mass of those popcorn kernels, that would be the molar mass of popcorn kernels. So the molar mass is just the mass of 1 mole of any substance. Now, as you saw in the last video, a mole of any substance is a stupid number. Like if you had a mole of pencils, it would not fit into your house even probably. And so that's why we really only use a mole to talk about atoms, because atoms are so tiny that when you get a mole of a sample, it doesn't take up that much space. In fact, a mole of water, okay, so H2O, a mole of water is only about 18 mils of water. So it would be a gulp. Right? 6.02 times 10 to the 23rd molecules of water is a really tiny volume. And that's why we use a mole for chemistry, because the atom is so tiny. Okay, so molar mass is the mass of 1 mole of any substance, and the label on that will be grams. So when I write the label for molar mass, that is then this label right here, how many grams I have per 1 mole. Okay, it's a conversion factor. It's a relationship. How many grams do I have if I have 1 mole of that thing? Okay. The periodic table gives you this information for any atom. And if I was counting for a compound, so if I'm counting for like H2O, water, or CO2, carbon dioxide, basically I can just count up what is the mass per mole of all of the atoms in the compound, add them together, and that will be the molar mass for that compound. It's the same idea that if like I got the mass of like this half of my calculator and then the mass of this half of my calculator and then asked you guys, well, what is the mass of the whole calculator? You just add them together. So if I know what the mass of the hydrogen part of water is and I know what the mass of the oxygen part of water is, I would just add them together and that would be the mass of the whole thing. Okay. So again, to review what we've done so far. The mole is an obnoxious number you don't really have to worry too much about, but the periodic table relates a mole to grams, and that will be a practical thing for us in the future. Okay? So let's practice a little bit about how to do molar mass. Okay? So you're going to need your periodic table for this, and I'll keep kind of pulling back my periodic table for you guys to look at too. So if I asked you, what is the molar mass of sodium? Okay? What is the molar mass of sodium? Well, luckily sodium is an element on the periodic table. So to report the molar mass of sodium, I just have to find sodium. And that number given to me is the mass of 1 mole of sodium. So the answer to this is just 22.990. Okay? So the mass of 1 mole of sodium is 22.990. And because I'm dealing with molar mass, that's the amount of grams I have per 1 mole of sodium. Now, if I'm looking for the molar mass of oxygen gas, the formula for oxygen gas is O2. So if I go back to my periodic table, I see that oxygen has a molar mass of 15.999. That's what my periodic table is giving me. So that would mean 15.999 is the mass when I have 1 mole of 1 oxygen. Now, since this chemical formula is O2, meaning I have 2 oxygens, in order to calculate that, I just need to have the molar masses of 2 oxygens that I add together. Okay? So if I have the mole of 1 oxygen and add it to the mole of a second oxygen, that will be the molar mass of 2 oxygens, which is what the question asked. So that would equal 31.998, and again, the label is grams per mole. Getting just a little bit more complicated down here, I have what's a molar mass of sodium carbonate. So in order to do that, I need the mass of sodium, I need the mass of carbon, and I need the mass of oxygen. So sodium we already looked up is 22.990. Oxygen we already looked up was 15.999. And carbon I referred to a couple times, but I also have it memorized. The molar mass of carbon is 12.011. Okay. Now, I could just add all those together, but that wouldn't be quite the final answer, because if I look back at my formula, I see I have 2 sodiums and I have 3 oxygens. So that means I need 2 times that molar mass, and I need 3 times this molar mass. Okay. So I'd have to add all of those numbers up together in order to get me to the final answer. So this is this many for the sodium, and then for oxygen, that one is this many. So now to get the total, I would add this one plus the 12.011 and plus the bottom one. And if I add all 3 of those together, I get a total molar mass for this sodium carbonate to be 105.988. And then you just label that grams per mole, just like we've been doing. Okay. The last example I believe I have on your sheet is not bromine, it's lead nitrate, which is PbNO3 Okay. So in order to add this up, I'm going to have to do the same thing as I did before for the sodium carbonate. Okay. So step 1, I figure out what Pb is. Step 2, I have to figure out what nitrogen is. And step 3, I need to figure out what oxygen is. So oxygen we already know is 15.999. Okay. Nitrogen, if you look at your periodic table that you guys hopefully have available, or you should open from the folder, nitrogen is 14.007. And then lead, Pb, is 207.2. Oh my goodness. Now, something you can do is just multiply those by their subscripts to get to the total rather than writing it out multiple times. So, for example, lead I just have 1 of, but nitrogen, because it's in this parenthesis, I'm going to have nitrogen twice. So I'm going to take that 14.007 and multiply it by 2. And then this O3 is also happening twice, but that means it's happening 6 times because each O3 happened twice for a total of O6. Okay, so that's one way to kind of shortcut yourself in terms of not having to add, but just multiply. So the nitrogens are that, the oxygens are this, and then the lead, since I only had 1 of them, is still 207. You put them all in your calculator, and I found when I put that all in my calculator, I get a final molar mass of 303.586. Again, grams in 1 mole. So if I had 1 mole of lead nitrate and put it onto a balance, it would mass out to be 303.586 grams. So there's your intro to molar mass. Go ahead and make sure you have all these notes done. Go take the tiny quiz on what molar mass means, and have a nice night.